I think that a lot of people, I've heard people call it like good student syndrome. Like you're used to being like in school and like you're doing well on your own, and then you'll sit in meetings and you'll just be silent, and you'll be listening, and it's not like it's collaborative like you were saying before. So you have to adjust to that.
The kid with the 4.0, he doesn't have to talk to anybody, or she doesn't have to talk to anybody, and it's like it's a completely different ballgame. No, you need to like cheerlead for yourself. You need to like have a team of supporters or sponsors that are gonna like promote you and advertise you and why you should be, up for whatever positions are coming up next. A
You can't
team
just be
of
awesome by yourself in corporate.
where do you kind of see yourself going next? We're going for VP. We're looking for that $1 million payday.
You know what's interesting?
Welcome back to the Custom Journeys podcast. Today we got another great episode for you. Really excited to be interviewing Tyrone Hill. He is a staff silicone architect at Google. He's going to kind of break down his career journey, how he got into what he's doing currently, how you can get into tech, some of the things that he looks for in terms of hiring or interviewing. He's actually a manager at Google, so he's responsible for leading a team. So for those of you interested in tech or breaking into tech, I think there'll be a lot of great value here for you today. And then also just overall good story. So very excited to have Tyrone on today. Tyrone, how are you doing today, man?
I'm doing good. How are you?
Doing great. Thanks for joining. I've been looking forward to this interview. Kind of behind the scenes look. You reached out to me, which was great. Like I love when people actually like listen to the content, tune in, and they reach out about being guests. So I'm very appreciative of that. But yeah, excited. So man, let's jump into it. You're in the Bay Area, right? Working at Google.
Yeah, I'm at Google. Google's located in Mountain View, California. I live in San Jose, California, which is about 15 miles south, and we usually work from home on Friday, so that's where I am today.
Okay, good stuff. And then I know I said the introduction of staff silicone architect. What does that mean, Tyrone?
Okay. So I think people know Google from, all of the software products like Google Search, obviously, Google Map, the Chrome browsers, things like that. Google also makes hardware products. So things that people might have in their house, like the Nest doorbell or Google Home device, or most significantly, I think for me, phones. So this is a Pixel phone. This is my phone, personal phone. So they make the hardware, and beyond like what you see on the outside, there's chips that kind of power the hardware, the CPU. And over the past couple of years, Google has pursued a strategy of making the silicon chips themselves. And I'm on the team that works on the design of those chips. So, what kinds of features go in the chips? What is the trade off in terms of end user experience with respect to power, performance, area of the chip, which goes into our cost of production, looking at all those aspects of the problems and making the best decision on the design to get a chip out every year and to give our users the best experience.
Interesting. Yeah, I've seen like this whole chip wars that's been taking place. I guess like maybe even a little bit before the pandemic. I really started to see like I think Apple. I don't know if they were the first ones to make.
They were the leader. Yeah. They started
Okay.
making chips for the iPhone. I don't know. It could have been like 2014, 2015, but more recently for the MacBooks. And so they started the trend where people wanted to move away from just relying on, say, Intel and Qualcomm and a few others. And people want to sort of make bespoke silicon that works with their software stack and is
Yeah.
tailored to their needs.
Hey, so what happens to the Intels and the Qualcomms of the world? Like if everybody's making their own chips and like even you're talking about the phones right now, but even like I'm a Mac user, so like even the MacBook Pros and the MacBook Airs, like you don't have any Intel products there. I don't know about like I'm not very up to date on like Windows products. So I don't know like if AMD is still, making chips for everybody there, but what happens then?
So it's a good question. So certainly there's this model where people want to make their own chips, but it's kind of a large proposition. Like even if you don't fabricate the chips, if you use a third party foundry, which lots of people do, not everyone is ever going to be able to make their own chips. So when we say that a lot of people are making their own chips now, it's really kind of the big players with deep pockets. Google has looked into this. Meta has looked into this. On the server side, Amazon has looked into this. But if you're, say, like Dell or you're Lenovo or you're somebody like that, you don't really have the budget or maybe the interest to make your own chips. And so you need to be looking at, say, an Intel or an AMD or a Qualcomm. Because a lot of companies are making their own chips, but they're not selling them to other people. So even though people making them, if you're not making them, then your marketplace is still limited to where you can source them.
Gotcha. Okay, so market share for Intel or AMD may go down a little bit because they don't have, the MacBooks or the iPhones or even the Google Pixels to kind of put their chips within that hardware. But they still have other players in the space that they can
Yeah, so
work
what
with.
I'll say is that it may go down significantly because, for example, even if you say Mac is a little sliver of the PC market, and I don't know the exact numbers off the top of my head, those are certainly the premium chips. And, like they sell for the most, and there's prestige like associated with that. So it definitely materially impacts them, but there'll always be people that will buy those chips. Like they'll buy the Intel chips. And I would also say kind of in terms of the performance wars between maybe Apple or Intel or these other companies, it's sort of always an ongoing battle. And even if company X is ahead now, it doesn't mean that they have an insurmountable lead that will never go away. So it's just kind of this constant, battle.
Yeah, that makes sense. It's business, constant tug of war, trying to capture more market share, all of that. I know you have like a Google Pixel. I'm a Mac guy or Apple guy. Like, I don't know why. They just got me in the ecosystem way back in college and I haven't left. I think a
Now
lot
you
of
get
people are
locked
like
in.
that.
I'm locked into Android. So yeah.
Okay, I was gonna ask you, like, can you be like an Apple supporter or like user even at Google, like, or they kind of look at you side eye if you like pull up with like your MacBook. Well, they probably have company laptops, but like if you pull up with like your iPhone or whatever to like a meeting, you put it on the table, like, are you getting like the side eye, like, what's wrong with this guy?
Oh, I mean, I think you can. I mean, I'm a, I'm a good supporter, so I definitely work with a Chromebook and have a Pixel phone. But you can do it. We're kind of easy about it over here. I think,
Okay.
at least in my team. So
All right, cool. Yeah, I was just kind of curious 'cause I know, like, I would imagine I used to work at General Motors, so GM, it was like they had designated parking spots for like GM vehicles, which were like closest to the building, and like if you had a non-GM vehicle, you had to park like way in the back at another lot, and it was like, hey, we're an automotive manufacturer, like this is what we're about. Like if you're gonna be driving your, I don't
you're
know, Tesla
Ford.
wasn't, huh?
You're Ford.
Yeah, if you're gonna be driving, yeah. I mean, F-150s are always like the biggest selling cars. So it's like, yeah, if you're pulling up with your F-150, like, hey, you go park that crap in the back of the lot. So I just didn't know if they had like something similar in the tech space or
No, 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 nothing
all
like
right,
that.
good stuff. And then like, is your job like primarily like electrical engineering related, mechanical? Because I think you kind of have, don't you have like a PhD in what, mechanical?
So I have a PhD, and we can talk about my journey, but I have a
Yeah.
PhD in electrical engineering. I actually had a mechanical engineering advisor, but I'm kind of far from what I was doing in school. So I would say my job is at the intersection of maybe electrical engineering and computer science. So kind of that computer engineering, computer architecture, that's the field that I'm working in today.
Okay, I had it mixed up, but I knew you had some kind of like reference to mechanical engineering. Let's kind of get into some of that journey. I usually don't ask this question as much, but I'm kind of curious. I know you have a twin brother, and both of you guys are kind of like in this tech engineering space. So I'm just kind of curious, like, what was kind of the catalyst for you guys wanting to pursue like engineering or technology? Was it something like growing up in the household, or what kind of inspired you guys to go this route?
It was definitely growing up in the household. So my dad, he was an engineer, actually more like a computer programmer. He worked at Bell Labs for a long time, and so
Like helicopter,
he
helicopter.
not Bell Helicopter, Bell Labs, which is was part of AT&T, so their
Oh,
research
okay.
arm.
Yeah, I remember.
Um, yeah, so he worked there. So I think we definitely got very early exposure to technology and programming. Like, like he had computers at home even in the 80s when we were kids. And like I know we were writing programs in BASIC, as kids. I remember being 6 or 7, and the first program he wrote with us was this program that counted to 100. Like it just printed the numbers on the screen. And he put, even back then computers were fast enough that it could do this very quickly. But I remember he put like a delay in the program so that it took like 48 hours or something like that. And I remember coming home from school and seeing, oh my gosh, finally reached a million. So I think I always had that exposure, and I was interested in technology and math, but honestly, I was one of those kids that like every subject I thought was like really, really cool in school. So I think the combinations of just growing up with a dad as an engineer and then just being curious about stuff and tinkering around with computers, that was also a big thing I did in high school. That sort of led me on the kind of on ramp, with an engineering major in college.
Okay. And then let's kind of like fast track. I know you obviously you went all the way from undergrad to PhD. Like, what were some of the stops that you, or some of the places you went for education wise?
So undergrad, I went to University of Illinois, Urbana-Champaign. So like very large engineering school. It's about 2.5 hours south of Chicago. I studied electrical engineering there. I actually, I'm in this sort of computer architecture kind of area now, but I was very interested in sort of silicon physics and the fabrication of the chips and the clean room and that kind of stuff. So I had a lot of coursework in that area. I ended up getting a scholarship in doing internships at Intel. So that was my first exposure to Intel. And actually, on my STEM journey, that was the first place. Even though I had a dad that was an engineer, I never knew anybody specifically that was African American and had a PhD. And
Mm.
that was the first time I remember I met like anybody black had a PhD. So that sort of incepted that into my mind. So I did my Intel internships. I did pretty well in college. So I ended up going to, directly out of that, going to MIT for grad school. I was at MIT for 6 years. I did one internship during grad school. I was actually here in the Bay Area at a national lab. So Sandia National Labs has a location in Livermore, California. I did research there. That was actually kind of more bio related. So it was sort of these microfluidic devices and like analysis of that sort of thing. So not very related to what I do now. And so after 6 years, did my PhD. My PhD was actually, and we could talk about this later if people are interested. There was some silicon fabrication, but it was actually the application is sort of high energy lasers. So definitely way off the roadmap from what I'm doing now. And it was very interesting, but I got to the end and I thought like, oh, okay, I have to get a real job and make money. So
Yeah.
I went back to Intel and I started working on desktop and laptop system design, like the power, performance, modeling, things like that. We did a lot of customer enabling. So beyond the technical work, I did a lot of going to customers and presenting. So I would go to like Japan and Taiwan, as well as even in the US. So a lot of these PC manufacturers are actually in Texas where you are. So HP is in Houston and you'd go to
Mm.
Dell in Austin and that kind of stuff. And yeah, towards the end, I got to get more into sort of the chip level architecture and power modeling and stuff like that. And then that gave me the opportunity to move to Google about 4.5 years ago.
Okay.
Yeah.
Good summary. Good summary, man. That the laser studies that you were doing in the PhD, that definitely sounds like some Sandia like funded, interested projects. I'm assuming that was like funded by some branch of the government.
Yeah, it's like DARPA and Sandia. Yeah. So,
Yeah.
oh, actually, no, Sandia was the internship, but the research is funded by DARPA. Yeah.
Okay.
Yeah.
What that's like
Yeah.
something defense something some acronym.
Defense Advanced Research Projects Agency, I think.
Okay, gotcha. I mean, it was smart of you. I'm not surprised. You're a smart guy. It's smart of you to figure out like, hey, okay, like I actually need to get a job. Like, what am I gonna do, and how am I gonna make that connection? How'd you end up landing that internship at Intel? Like, or you had the internship at Intel as an undergrad. What was the one that you had as a PhD? Was that at Intel too, or another one?
Oh no, that one was at Sandia.
Oh, okay, that one was at India.
And
Okay, gotcha.
I just applied. Like I was looking online and I like just that one was actually just out of the dark. A lot of other things I've gotten, like I've had a connection, but I would say in
Yeah,
my career that one was a shot in the dark. And then actually coming to Google was a bit of a shot in the dark because I didn't really know anybody at Google doing hardware or anything like that. It was just kind of like, oh, this opportunity is here. So let me try.
interesting. Did you apply online, or did a recruiter reach out to you for like for the Google one, for example?
Oh, a recruiter reached out to me, but it wasn't like I had a network. I mean, I knew
Yeah,
people
you
at
didn't
Google,
know
but I
somebody
didn't.
there that like said, "Hey, apply for this role."
Yeah, yeah.
Okay, gotcha. Oh man, that's impressive. Yeah, I know. So I worked at Sandia too. I know I told you this off camera, but got to say it on camera for the people to know. So yeah, I did an internship at Sandia while I was like going in between undergrad and my master's, and the way I got that one was like somebody. There was a guy that used to work at Sandia. He was a professor at UTSA, University of Texas San Antonio. He invited a speaker to come out from Sandia. He made an introduction between the two of us, and he was like, "Yeah, apply next year." Because I think it was like too late in the game or whatever. But he was like, "Yeah, you'll get it. Like I'll definitely." Because it was essentially it was his intern, and so it always helps when you know somebody.
That's the way of the world, you know.
The way things really work in this place, it's not just meritocracy of like, hey, you got a 4.0, you deserve this. It's like, no, who do you know?
Oh no,
And
not at all. Yeah, I hope everybody, all the students, yeah, it's important to have the 4.0, but it's you need more. So yeah.
going back to your time at Intel, you started with an internship first, right, during your undergrad, and then that was your first stop after college. Did you land that position because of the relationships you built through the internship at Intel, or like how did you land like the full time job there after you graduated?
The internship, the first one I kind of landed just from the scholarship. And I was really young. Like my first internship was actually like I was a freshman. I didn't really know anything. So
That's like so rare.
the,
It's like, what do you know at that point, But
no, and
maybe
I
it's
looked like
invested
I
in
was
you.
like 12. Yeah, yeah. I mean, I got a lot out of it because it's like you do things like you're doing circuits, you're doing programming, but then it's like, okay, no, you have to like write C++ for real here. So that was helpful. And I had kind of like a weird thing. So I got out of undergrad and I actually graduated on an off semester. So I graduated like in a December and then I wanted to go to grad school in the fall. So I worked for 9 months before. And like the team I worked on was just kind of connections I had made through previous internships. Yeah. It was like after the very beginning, it was just all about connections. Yeah.
Yeah, no, that's a good point. I graduated in December as well. My first, actually, both times I graduated, and you're definitely like kind of off cycle, I guess, in terms of like when recruiting is
Recruiting
primarily
and
happening.
yeah.
So definitely got to be resourceful there. How long have you been at Google now?
I started in August of 2019. So about 4 years, four and a half years almost.
Okay, let me back up actually. So I think it may be some value in kind of just, asking you a little bit about like the admission process to MIT or like going to MIT. I know it's kind of like prestigious university, can be kind of challenging to get into. Like what was that application process like and what do you think kind of really helped you get into MIT?
But it's a good question. So I know that like when I was like a sophomore or maybe freshman or sophomore in college, I was like really, really interested in like grad school, you know. I just thought like after I met this guy, like this black guy that had a PhD, I was just like, oh, I'm really interested. And I remember talking to him about like, oh, what does it take? And I think I was at some kind of conference when I was a freshman or sophomore, and I met someone who was like a dean or an admissions officer at MIT. And I remember talking to this woman and her saying to me, oh, the most important thing, like we don't really use GRE scores because everybody has high scores. The most important thing is undergrad research. So that actually, once I heard that, like that became my goal. So I know a lot of schools now have sort of undergrad research opportunity programs, either like in their school or you can go to another school over the summer and do undergrad research. So my school, University of Illinois, had that. And so I very consciously, the professors that I did very well in their classes, like I made myself known to them and I ended up doing a research project with one of my semiconductor physics professors. And you kind of learn about research, I think, at the undergrad level, but like for me, it's not really like you were publishing anything or doing anything incredible. It's kind of just to get exposure and then to really be able to get a strong recommendation from a professor. So that was part of it. I did do GREs, but that was maybe more for like fellowships. And then the application process, kind of very typical, kind of like college. You had to write an essay, but it was more about like a research statement, like what you wanted to do. But I think the scrutiny of the grades and then really having strong sort of professor recommendations was the most important thing.
Man, I like the strategies that you implemented. Talking to the dean gave you like an inside look at like what do they value, and then it's a very smart decision. To reach out to the professors you got an A in their class and reach out to them and say, hey, I would love to work in your class. It would be really bad idea to, reach out to somebody that you barely passed their class and be like, yeah, I would love to work for you. And they're like, you didn't even
Who are
really pass
you?
my class. Like, why would I do that? So, good idea. How did you fund it? Like, did you get like a fellowship, or I know there's like the NSF fellowship. There's Lewis Stokes Alliance for Minority Participation, or LSAMP. Like, how did you kind of fund your research studies, both on the undergrad and on the grad level?
So undergrad, I went to University of Illinois, but like I was living in Ohio, so I was out of state. And then I was in the honors program, so they knocked down some of my tuition. And then I think I had loans the first year, but then I ended up getting this scholarship from Intel, which kind of took care of the tuition. It was actually very nice because it took care of the tuition, and then I had these internships, and I had enough money for room and board. So between that and undergrad, and then I told you I had that 9 month gap where I worked before grad school. I think the 9 months was enough where I think I had some debt, but I actually paid off the debt before I started grad school because I just had cash. So it worked out very nicely for me. For grad school, I actually got a fellowship the first year from MIT. Like MIT had like a named fellowship for like an older alum. So I got a fellowship for that. You're right. A lot of people did like the NSF fellowships or Department of Defense fellowships. I had actually gotten a GEM fellowship,
Okay.
but then I ended up having to give that up because I had other fellowships. And then the
Making too
professors
much
like,
money.
well, yeah, like they were like, oh, well, you have these other fellowships from MIT. Like, why don't we give the GEM money to somebody who needs it, which is fair. And then, most of the professors have money. They have a budget for like research assistants. So I think the common paths besides fellowships are either you're a research assistant, you're working for a professor, or you're a teaching assistant. And yeah, I would want to emphasize to anyone listening considering grad school, you should not have to pay for a PhD. Like there's something wrong if it's not like either you're teaching and that's funding you, or you're being funded for research, or there's lots of money out there. I mean, I can see, and I certainly knew people who had like a shortfall in like a semester or something, but like in general, I feel like there should be somebody
Yeah.
paying you.
I agree, 100%. Hey, quick question. Like, so you've been at University of Illinois, Urbana-Champaign, MIT, Intel, Google. It's kind of like a broad question, but like, what would you say has been like the most challenging like place to kind of work at or be at, like from a technical standpoint?
I think that MIT was kind of a shock. And it's not because like, oh my God, like everyone's a genius and everyone's like everything's so hard, but it was sort of like a psychological shock to be at MIT. I think that there was a culture of intensity there that you had to adjust to. And then when you get in, no matter where you came from, and I think this is the case if you came from high school or you came from another college, there's this like, oh my gosh, I'm at MIT. And then like this sort of anxiety and, I guess what you would call imposter syndrome. But like once you kind of get past that and you kind of see that, everybody's kind of like you, that gets a little bit easier. So that was like a big barrier. I think there's also a big barrier. There's one thing being in school wherever you go to college, and then being in the work world, because in the work world, you're working with people who are very junior like yourself. There's very senior people you're working with, different backgrounds, different age ranges. And then, you can't really rely on the past. Like when you're at Intel, you can't be like, oh, I'm so and so from MIT. Like nobody cares. Even like, and you're at Google and you're like, oh, well, I was this and this and this title at Intel and I went to MIT. It's just like, yeah, that's nice, but nobody really cares. So having to build those coalitions on your own, with people very different from you, I think the big puzzle challenge to figure out in the work world that you don't have in school.
Did you just kind of figure that out like on your own, like on the job, or did you kind of have like an older person, like a more senior person within the organization at Intel or Google, kind of like mentoring you or kind of giving you game on what to kind of expect or how to like leave your mark on the company?
I definitely had mentors helping me, specifically at Intel. I had mentors. I was in sort of career development programs. But even, it's interesting. Like, one of the things that people would say when I was in school, specifically grad school, is, there's this aspect of undergrad and grad school, like you have academics, but then there's like people who are involved in extracurriculars, like they're captains of teams, they're in
Mhm.
student government, things like that. And, I was involved in that stuff when I was an undergrad, but then I thought of it as kind of frivolous in grad school. But there is this part of all of that stuff, even though it's not academic, where it teaches you to work with people and kind of form coalitions to solve problems. And I think that those skills are important in the workplace in a way that, a lot of students probably don't fully understand at the time, even when they're involved in those activities. So that was a big help to me also.
Yeah, that's a great point because I know like if you're not going out of your way and signing up for like SAE, Society of Automotive Engineers, and like building a car or some other like student org, a lot of times you don't really get those opportunities to work on teams, which is in corporate a lot of the times what you're doing. Whereas like in academia, is like work on this project by yourself, figure this out for the next 5 years, write a dissertation, and you're good to go. But corporate is completely different. It's you're a
You can't
team
just be
of
awesome. Yeah, awesome by yourself in corporate.
Yeah, exactly, exactly.
Oh,
Earlier, you kind of mentioned like some of the project that you're working on right now in terms of the advantages or why you may want to like develop your own chip in house at Google. I'm just curious about like the pros and cons a little bit of the two. Like, why would a company just kind of digging deeper? Like, why would a company want to move everything in house versus like doing the things the way they've been doing them? Like, is it like a cost saving measure? Is it from a technical standpoint? I even saw like I think Google or not Google, Apple had like their keynote announcement and they talked about like I don't know what chip they're on like now, M2 or M2 Pro or maybe even M3, I can't remember, whatever. But talked about hey, it's gonna have applications for like machine learning and AI, and I'm like, okay. They kind of like breezed through that, but like even some of that, like what are you gonna be able to do now that they couldn't do before by developing this technology in house?
so, a couple things. So yeah, like I think Apple's on the M2 maybe, and that's like for the MacBook and the iPad and like maybe A17, I believe, for the iPhone. And so it's all about differentiation. So if you rely on Intel or you rely on Qualcomm, at least from a hardware perspective, whatever they decide for machine learning or whatever they decide for multimedia or even the amount of memory and things like that on the chip, it is what it is, and everybody else has that sort of advantage. Like, Apple has that if Google was using the same chip, if whatever other cell phone company was using the same chip, everybody has that. And then the only way to differentiate is on software. But if, Apple is designing the hardware and the software together, which you hear people call co-design, and they say, hey, we want to do this certain kind of ML model, we want to do it, we want to do it on device. And we know that we'll need this kind of memory, and we want our ML accelerator to run at this frequency to get this kind of latency to get the best experience that we can offer. And they want to do that in a way that's very specific to their advice, to their device. The only way to really, really, truly do that is to design both the software and the hardware. It's sort of an advantage that you can't get just outsourcing the hardware like completely to another company. And then also, I think from a planning perspective, if you have the capacity in terms of the engineers and money, it helps your product cycle, because if you're Apple and you're completely reliant on a third party vendor, and then they have, a process problem or they have a functional problem, it sort of can throw you into disarray in a way that you can't control as tightly.
That makes sense in terms of the control. It's a little surprising like so my experience with like General Motors working at GM, like they're a car manufacturer, but like there's like hundreds or maybe thousand like suppliers that create different parts. Like the steering wheel is coming from one supplier, the airbag is coming from a supplier. But though a lot of times like those are built to like specifications that like General Motors wants. So like is that kind of the same way it works like before? Like would Google or Apple say, hey, Intel, we want a chip that can do XYZ and make it this way? Or would it just kind of be like Intel's like, hey, this is what we can do, take it or leave it, like this is where we're at, like in terms of technology? Or like how does that like I guess in the old way of doing things, like how does that kind of work? Is it not really much
So
collaboration?
No, it's a good question. I think that in a way the ecosystem and the supply chain is similar in that if you would look at the iPhone or you look at like anybody's phones, there's hundreds of vendors. There's people making the printed circuit boards. There's people making the resistors, like the microphone sensors, the memory. There's lots of sort of components to the BOM. I don't know if you use that word BOM, bill of materials, in GM, but just to define it for the audience. But let's say maybe the way I would make it analogous to a car is like, let's say you're making a car and you have a total like bomb of like the car cost $30,000 to produce, and that you had one component. So let's say the engine costs like $25,000 or something like that. Like there's kind of that analogy with a cell phone at least, or even a laptop. Like there's a huge premium on the processor. So it's kind of touchy to sort of leave control of that completely to another company. And now the second part of your question was, is there collaboration? There is collaboration. Like, for example, if you had a key customer, like let's say you were Apple working with AMD or working with Intel or whoever they might work with now or in the future, since they're such a big customer, they definitely would have inputs to what the design would be. But you would, of course, probably have other customers too. And then if you're the supplier, like if you're Intel or AMD, you need to balance the requests of all your customers, which may be contradictory. So every individual customer may not get exactly what they want.
Yeah, that makes sense. I love the analogy, the car analogy, comparing it to the engine, and that makes sense. It's like this is the most important thing in the phone. Why would we trust somebody else with that? Plus, you just like you said, you get more options if you bring that in house in terms of like what you can build and create.
Yeah, and just to add to that, let's say the engine was like, 80% of the cost. And then the way, at least in the PC market, Intel had set it up is like the engine is actually advertised to the end user. So if you remember in the 90s and 2000s, or even now, sometimes when you see a laptop commercial from like Dell or Lenovo, they'll say,
Yeah.
oh, it has an Intel processor or an AMD processor. So if an
Yeah.
engine in a car was advertised like that, it becomes especially like, you know,
Yeah, that's a good point.
it's touchy.
Yeah, I mean Intel for sure. Like I wasn't as familiar with AMD earlier in the earlier days. I know they're like their company is growing. I guess recently, at least like the
Yeah,
stock price was. I was paying attention to that. But like I was like well aware of like, hey, it's Intel i3 or i5 or i7 or even an i9. Like to your point, like that doesn't
put
happen.
that in your brain. Yeah.
Yeah, so it definitely sticks. It's like, okay, the higher the number, the better. And it's like, you're thinking like that's how you kind of value the computer in a sense. It's like, okay, oh, this only has an Intel i3. Like, nah, you're not gonna like look at it the same. So that's a good point, man. I know. I would imagine Intel is very pissed off at the moment that it's like, they're having to undergo all these changes. So did you kind of make the switch from Intel to Google like as this change was happening? Is that kind of what sparked your change from Intel to Google?
I felt like I had worked there a while and I was sort of looking for something different. So I wouldn't say like the current changes are my reason for leaving. But I think that this is kind of like a cyclical. All of these tech companies are the ones that are around for a long time are sort of in this cyclical battle because, like Intel has been up in the past, Intel has been down. I feel like AMD is sort of getting a lot of buzz right now for the things that they're doing, but there's been times where they've been doing very poorly. And even when I was in, I don't know, I used to follow this stuff when I was in grad school, like the maybe 2005, 2007. There were certainly times even back then where their processors were probably performing better than Intel. It's all cyclical, Intel's had some process problems, which I think, people are all aware of now publicly. But I don't know that any of these companies, any of these players is kind of down in a permanent way. So you just, you kind of look at those macro sort of events and things are going on. And then you also maybe look at where you are personally in your journey and see if there's opportunity for you. So that stuff's
Yeah.
important, but it's not everything.
I know you said it's cyclical, but like who would you kind of bet on like for coming out on top between like the Intel, AMD, Qualcomm? I don't know. I would kind of exclude Nvidia because I know they do like GPU processing, but like of the other three that I mentioned, who would you kind of put your your money on, or my money on, I guess.
You're saying between Intel, or Intel, what are the three that I'm betting on?
Intel, AMD, and Qualcomm, but maybe there's another player or other players that I should be aware of.
So it's kind of it's interesting. So let me segment it a little bit. So Intel and AMD are making, they're making like desktop, laptop,
Mm.
gaming processors. They're doing some data center things, but the biggest thing that links them is the sort of instruction set architecture. So they're using the x86 architecture, which is, kind of created by Intel and then licensed to AMD. Whereas Qualcomm is using ARM, so the advanced risk machines, their architecture, so their instruction set. So it's a slightly different computer. So I would put AMD and I would put Intel sort of in a boat by themselves. I think long term, the question for me is what is the longevity of the x86 architecture? So right now, since we've had Intel and AMD products, in a lot of sort of desktop and laptops and running Windows, we have x86 architecture, but Qualcomm and all these other players are using ARM architecture, which at low power, so when you think about smartphones, is traditionally more power efficient. So that's kind of starting at the bottom, and then it's sort of, will it be able to eat its way up into the sort of laptop market? I think Apple is starting to do that now. The fact that they have like the M1 and M2 processors, which are ARM processors. And so I would say the longevity of, Intel and AMD in some sense kind of depends on whether or not that sort of ARM architecture sort of eats the market. And to me, it doesn't necessarily mean that they fail just because of that, but that's a big factor. And do they have to change their strategy? Do they have to give up x86 or do they have to do something different to survive?
That's some good insight. I appreciate you breaking it down. Like as you were thinking or speaking about like the ARM technology, I got kind of curious about like what are you most excited about in this space, like that the general public may not even know about. Is it the ARM technology or is it something else?
I mean, it's not the ARM technology. I think that's something it's interesting if you want to geek out on that. It's there. I'm really interested in, everybody's doing, the hot thing now is sort of like, everybody's interested in AI and machine learning. And then there's sort of different philosophies of like, am I going to do all that stuff on a server in the cloud and beam it down to phones and tablets and laptops, which we call it the cloud, and then those devices that you hold in your hands and have in your house, we call it the edge. So am I going to just do all my sort of heavy machine learning in the cloud and just beam the results down? Or am I going to try to do some of the machine learning computation, which people call inference? Am I going to do that on device? And there's sort of, a lot of constraints to doing it on device, but even sort of when you step out, what is the most energy efficient way to do that? How to solve that problem, whether or not the server wins or the cloud wins or kind of on device wins. I think that is a big sort of question that will say what are the winners, what companies are the winners sort of in computing, in the next kind of 10 years. So like if we do it in the cloud, are we living in an Nvidia world? you know if we do it on device, there's all these startups that are trying to do kind of low power on device machine learning. Obviously the Apples and the Googles have their sort of solution to edge ML. Also, it becomes a different kind of story depending on where we kind of go with all of this.
So energy is one thing that I've kind of picked up from you speaking. Like that's important. Like low energy, making sure that you can like limit the amount of energy required. I'm assuming like security is also like another like high priority, like for some of this as well. Is that like what are those kind of like key factors, like that kind of influence some of the decision making, or why like somebody may like do most of the computing on the cloud versus like on the edge? I'm assuming like energy and security are two of them.
So I think from a kind of business standpoint, I would say I think energy is a big one because it's like there's like kilowatts, megawatts, whatever watts that all these companies are spending on their data centers to serve all of these sort of requests. So I definitely think from a business dollars and cents size, that's important. I think security, I mean, I think businesses care about that use sort of cloud services and devices, but I also think individuals care about that. So one of the arguments actually for doing machine learning on device, for both sort of inference of models and training is, if I have a machine learning or an AI use case that uses my personal information, if it uses my health information or my credit information, or it uses something personal that I don't necessarily want released in the real world, can I do that kind of training on device and then maybe beam up the results so I can have my data sort of protected? There's a whole field called federated learning where people kind of talk about that in solutions. But I think that security is important from that perspective. And then also, yeah, if we're doing it for anything health related or financial related, to make it compelling to end users, it's also a concern.
Okay, good stuff. Hey, so kind of final question along this line of questioning. I want to definitely talk about like your experience as a manager and a people leader within Google. But if like somebody's interested in the space and curious, what would you kind of recommend, like in terms of opportunities for growth or opportunities for employment within like this tech ecosystem? Is it, looking at chip design? Is it looking at arms technology? If you had to, I know we're all kind of talking about the same subject, but like if there's like one specific niche that people may want to check out, what would you kind of recommend that they pursue or just kind of be curious about or like investigate?
There's different angles to sort of get into, like, if you wanted to do my job eventually, there's different angles. Like for me, I did electrical engineering, I had all these degrees and stuff like that. But the thing that I really had a lot of experience in was like power. So I started, like I knew a lot about power, and I started thinking about power efficiency of, kind of devices and architectures and stuff like that. And that's kind of what was kind of like my entry into reading about things and sort of getting knowledge. So you could sort of leverage kind of where you are now, and either from background or from interest. Um, I actually think, one of the nice things about machine learning and AI is that it's all like a relatively new field. So the foundational paper, that a lot of people reference for a lot of these large language models was actually written in 2017. Just to give you a sense of how new it is, it's this paper called Attention is All You Need. So basically, from kind of reading papers online and like trying things in sort of Python collabs, I think that there's sort of an opportunity, assuming you're comfortable with programming at least a little bit, to sort of educate yourself. So that's another angle. You're just kind of either leveraging your background now, or I would say kind of look at the resources that are out there. And then also, I always tell people use LinkedIn as a resource, because if you see someone who is doing something similar to what you're doing, maybe you can talk to them. Maybe they have ideas. They may not have a job for you, but like, I certainly have had people reach out to me on LinkedIn, and I've had informational interviews and talked to them and tried to point them in the right direction. So not like a straight answer, but those are some thoughts I have.
That's still valuable. I appreciate that. And then let's kind of dig deeper. You mentioned in your current role, you're in a leadership role, you're managing a team, you're interviewing, hiring, all that good stuff. How big is the team that you have right now?
So right now it's pretty small. It's just three, and then I've been sort of like a tech lead for a larger team. Tech lead means you kind of set the technical direction, but you don't like manage them on paper. And it's been three. Sometimes it's with the tech lead people, it's been like six or seven, but three right now.
Okay, good stuff. So let's help these people. Number one, that are looking or interested about getting into Google. It's obviously like a very popular destination, very in demand job. What are some of those different pathways that you recommend people take to potentially just be employed by Google? Whether it's software engineering, whether it's getting into chips or whatever the case may be.
So yeah, so if your interest is software engineering, because like Google, like I do hardware, I do chips, but Google is a software company, so the most opportunities are in chips. And I think that the interview process is very sort of standardized for that. In terms of skills, like I think a lot of people are familiar with the software engineering sort of interview process. You would, do an interview probably online. They would ask you to actually write code like on the spot. And so that's something, there's like knowing how to like write code to solve kind of problems. And then there's having the comfort level that you can do it under pressure. So definitely preparing for that. There's lots of resources to do that. Like I know some universities do interview workshops. There are those websites like Leet Code is one of the most popular ones that people pursue. So definitely like preparing on your own. And then in terms of, actually getting the opportunity, I always tell people, and especially maybe this audience, like, you're in college, you're going to have career fairs to always have your resume, get it within like 1 to 2 pages. If you can do things like, if you can go to like the NSBE conference or the SHIP conference or the Tapia conference or Grace Hopper and sort of get in front of these companies. And then I'd also say, even if you said, oh, hey, my ultimate goal is to get to Google, you should do as many interviews as you can because, any interview you do is practice, it's experience, and it's that comfort level. So don't just be so focused on like one company that it's like, oh, I'm only going to talk to this one company.
Yeah, I think that's good advice. I mean, even like the smaller companies, I think, like I know people definitely, there's a sexiness to like the Apples, the Googles, the Nvidias of the world. But even if there's like a startup company that, you can interview with, because maybe things don't work out with you, Google, at getting into Google on the first try, I think number one, good interview practice. Number two, great experience that you could gain, just in general. And I mean, that's only going to like strengthen your resume and make you a more attractive candidate.
Yeah, and just related to that one point, it's like most of the people that I work with at Google, it's like it's not like they came out of school and worked at Google. They might have worked at a bunch of small companies. They might have worked at like a lot, some people even they worked at like a non-tech company doing software or hardware. Like they worked at Disney or they worked at General Motors or they worked at, you know, it's also regional. Like a lot of the Texas people worked at TI or they worked at HP or they.
Yeah, that makes sense.
Yeah.
Makes sense. When you're interviewing or like when you're like reviewing resumes and stuff, what's one of the biggest things that like you kind of look at or like I'm assuming you've hired. I didn't ask you that beforehand, but like, what do you? Okay, perfect. So like, what are some of like the biggest things that you're looking for? Like when you're reviewing a candidate's resume, is it kind of like a checklist? Like, okay, hey, if they went to like an Ivy League, that's a good box to check. It may not be required, but hey, X amount of experience, certain employer or whatever. What are some of like those key factors that you're looking for when you're reviewing a resume?
I mean, I think, and I think that's been a problem in the tech industry. I think people are trying to get away from that. I think there's certainly a time when people are just looking at like, oh, or somebody like an Ivy Leaguer or like whatever school. You do like when you look at an undergraduate or a master student, you would look at certainly their coursework and the skills, and you would look at internships. That would be a big thing. But really you're kind of looking for, yeah, like evidence of like, I know that I have 1 2 3 4 5 skills in the job, and like in the first screen I would be looking for evidence on the resume, like specific keywords that I know, like, you have to know Python, or you have to be good with like, Excel pivot tables, or you have to have sort of like a circuit background. I'd be looking for that sort of evidence of that in the resume. And then in the first phone screen, I would be looking for evidence of that too. And then in the later interviews for an entry level candidate, you probably would probe that also, but then you would want to look at problem solving ability. So, if I gave you a related problem in that domain, could you work to a solution? Could you kind of come up with a strategy and then I could help you through? And then could you know enough that you would know that, oh, I'm missing X piece? And then, hey, Tyrone, the interview didn't give me this piece. Like, can I ask a question? Yeah. Like, can you reason through the problem? Because, when you're actually working, it's not like, you have a problem set and I have a prompt and there's this exact answer.
Yeah, you got to kind of figure out what is the problem, number one, like, and then
Yeah.
investigate like why is this happening and kind of dig deeper from there. Great input. I don't think we talked much about like day in the life for you. Like, what does that typically look like? I know you're like a manager now. Kind of walk me through that experience in a typical day for you.
Typical day, I get up, I kind of deal with my son in the morning before we get him squared away with childcare. So like an hour, like feeding him breakfast and stuff like that. I go to work. There's a lot of traffic in the Bay Area, so it takes me about 40 minutes. I get into work. The one thing I'll say is like you always have to make time for yourself. So like I work out for like 45 minutes at work.
Yeah.
And then I kind of sit down at my desk. I like to have maybe until 11 just kind of free to just kind of think about stuff and look at email. And then I usually have maybe like a couple meetings until like maybe 12:30. The busier I've gotten, I usually do lunch at my desk. That's my price for like working out. And then I'll probably have maybe two or three meetings. We have like scheduled sort of working groups, and then I have one-on-ones maybe in the afternoon. So I'll maybe have two to three meetings, and then I'll go home around 5. I'll get home around 6. You'll see this with a lot of people with families that maybe from like 6 to 8, you're with your kids, you're doing bath time, you're doing dinner, family time. And then maybe from like, usually maybe from 9 to 10:30, I'm either in meetings. So we have a lot of international people. So we have people from like people in India, people in Taiwan.
Mhm.
I'll do meetings, or that's actually a good time for me to work. And then, yeah, I'll go to bed at like 11:30, and then I'll do it again. Before I had kids, it was very different. It was kind of more, I don't know that I had to use the evenings the way I do, but like because I have a family, that's kind of a typical day. But just to be specific about the meetings, like I have several kinds of meetings. Like we have sort of working groups or task forces where we have, we're kind of trying to come up with a design or solve a problem in a group, and then participating in that. And then sometimes I have to do my own technical work so I can present out to those meetings, or it's like an initiative that my team's doing. And then I have one-on-ones with my team members where they're going to tell me about their progress and their roadblocks and how I can help them. And then also, yeah, I have to have one-on-ones with my manager where I have to give status report and updates and things like that.
Like, how technical are you, I guess, at this point? Like, where you're on, I feel like the managers, a lot of times, you may have to spend more time than you want, like just, leading people and resolving issues there. But do you still kind of like get into like the technical details a lot or what?
So you do get into the technical details. And the reason that I have to get in the technical details is like I have to explain it. Like when I go talk to the director or I go talk to the VP, it's just me. So he's gonna ask like our VP is very technical, so he's gonna ask technical questions. So you at least need to know. But it's not, the first year I was at Google and we were doing our first chip, it was like I was doing the bring up of the silicon. I was doing power measurements myself. I was writing lots of code. And I don't do as much of that stuff anymore. So it's less hands on technical than it was.
Okay, gotcha. And then I guess another a follow up question. You mentioned Python. I know you said just now, like writing some of the code. Even though you're a hardware guy, you're still doing like some coding. Like, how much coding or like what is the coding typically for if you're like focusing on hardware?
So I in my career, I've done a lot of sort of system and chip level power and performance simulators, where we want to simulate like what's the latency, what's the power. And so we used to do that stuff in like C++, and now we do that in Python. And yeah, it's just sort of like, I feel like if you've learned other programming languages, Python is very sort of intuitive and easy to learn. So there's kind of that simulation work. And then also in general, I think a lot of people, maybe even students, would see Python as like, it's just a very nice language to process data. Like if I have like gigantic data sets, I can, use like NumPy, or I can use pandas, I can put it in data frames, I can visualize the data in interesting ways. So that's a big thing that I still just do myself. And then a lot of stuff like in the lab, like automating measurements and stuff like that, you might use Python, or you might use like bash scripting, just like general sort of Unix scripting to do that sort of stuff. Um, but mostly data processing. That's kind of where most of my coding would come from today.
Okay, good stuff. Yeah, no, I would definitely say Python was like one of the more intuitive languages. You know, I started with MATLAB, then Python and JavaScript, and it reads like English, whereas like some of the other coding languages, I'm like, what the hell am I doing? So,
Yeah, I used a lot of MATLAB in school, in grad school, and then yeah, it's like a big transition. Like, okay, we have to use Python now.
I know you said like a typical day is 9 to 5, and then you have the meetings in the evenings and things like that. And I don't know if some of that comes with like your role as a manager specifically, but do you feel like the trade off is worth it? Like in terms of like you obviously have like a wife and kids and things like that now, and like your lifestyle's a little different. But do you feel like that trade off is worth it? Because I do think like we all have like this end goal. Like if I could be a VP, oh my God, that'd be perfect. Or if I could be, whatever, or start my own startup, it'd be like perfect. Or my life would be amazing. I'll make a lot of money and everything else. But I think sometimes we don't look at like the cost and like, is that kind of like the lifestyle that you want to live? So I guess for you specifically, like, do you feel like that trade off is worth it at this point?
No, no, I think it is, and you're right. It's kind of like a trade-off between, money and time. But like you have the opportunity to do more interesting things, to see progress go forth. I also think a lot of the things are, your life moves in phases, right? So it's like I have to work late nights, but part of that is because I have like small kids, right? If my kids were like teenagers, I might be doing the same amount of work, but it might not be structured like this, right? So it's kind of like you're doing this and there's times when it's kind of hard, but it may not always be that way. And if I'm honest, like even if you weren't ambitious, and part of this is just like what life you have. Like if you have a family, right?
Mm-hmm.
Like you have a family. If you have a family, no matter what job I had, like I would still kind of have the challenges, and I'd have the late nights, and I'd have the early mornings with the kids anyway. So you might as well do something that you find interesting or fulfilling.
Yeah, I agree 100%. Right. It's always a compromise. It's always changing. Right now, walking my kindergartner to school is like one of the top priorities for me. So I kind of build my day out around that, like making sure that I can spend that time with him, walking him to school. So, yeah, you kind of adjust. And like you said, it's a lot of times you'll have the same situation regardless of what job you're in. Looking back on your career, like if you had young Tyrone, young 24, 26 Tyrone walk into Google right now and they were kind of looking to you for advice and they just kind of like, hey, like this is where I'm at. I'm trying to figure out where I want to go within the company, and maybe you guys kind of work hand in hand, and he decides, hey, I want to be a manager like you, or I want to be a tech lead like you were. What advice would you kind of give that younger version of yourself in order to like be successful or to accomplish those goals?
What I would say is one, kind of work hard to have a thorough understanding of how this company and how this team works, independent of your work, and kind of talk to a lot of people to understand that. And then the number one thing, though, beyond that is sort of like be confident in yourself and your abilities. Like, I don't know, like people say, like swagger. Kind of be confident to propose stuff, be comfortable enough that you might be wrong and you don't have to know everything, and yeah, sort of like build sort of relationships with people. Those would be the biggest things. Because I think that a lot of people, I've heard people call it like good student syndrome. Like you're used to being like in school and like you're doing well on your own, and then you'll sit in meetings and you'll just be silent, and you'll be listening, and it's not like it's collaborative like you were saying before. So you have to adjust to that.
I've never heard that term, but I mean, I think that's a perfect like analogy, right? Because like in school, like the kid with the 4.0, he doesn't have to talk to anybody, or she doesn't have to talk to anybody, and it's like it's a completely different ball game. No, you need to like cheerlead for yourself. You need to like have a team of supporters or sponsors that are gonna like promote you and advertise you and why you should be, up for whatever positions are coming up next. Nice. We've already been talking for an hour. I can't let you go though without like at least trying to ask you about like some money questions related to this thing. What kind of lifestyle we live in, Tyrone? Like working at these, tech companies and in the Bay Area. Are we talking like high six-figure salaries, stock options? Like what are some of the benefits from a financial standpoint? Or maybe even if you can share like expected salary and stuff like that for some of these like tech roles that are out here.
Again, I'll preface this with like things are like very expensive here. But like yeah, like I would say like broadly someone who is coming to Google, and you could find this like there's different websites, like there's like levels.fyi is a big one. there's Glassdoor. Someone coming out of school, I think their total salary, and that's like your base salary plus your stock and things like that, I think should be in the sort of like your base plus your stock and your bonus, like you should be sort of in like the mid to high 200s at the bottom. And then it goes, up and up and up and up and up. Like, so somebody who's like a very, very senior engineer, like, beyond me, it could be making like $1 million a year. Again, that's not me, but that's kind of the range.
Is that like a
Yeah.
leadership? Like you talking about up to $1 million? Is that like a leadership position? Like you talking about like director level, or are you even just talking about like just purely technical, like a tech
I,
lead or senior tech lead?
I'm mostly talking about director level, but there are certainly people who are like software engineers and they've got like 20 years of experience and they're kind of maybe very senior at Google or Meta who are probably making that.
Crazy.
That's
Okay.
that's the rarity, but like,
It
yeah,
happens. Okay.
yeah.
Gotcha. I know sometimes people can't really divulge too much information, or it may not be, smiled upon by the powers that be. So I'll ask you at a place like at Intel, like how much money were you making at your peak at Intel? Is that something you can
Mm,
share, or is that kind of
no, no, I can share it. I can share it. But you have these components. You have your base salary,
yeah? If you
and
remember
then
the
you.
breakdown, feel free to share it. Like if you do remember the breakdown, that's
So
fine.
what
But
I
if
don't
not, it's fine.
remember is the I don't remember the stock. The base salary was like, and this was like I'd been there for 10 years. It was like 190, something like that. And then, the biggest thing between Intel and other companies is like the percentage of your total compensation is stock. Because it's like I would say you kind of get close to either 50% or more than 50% of your stock as you get more senior as like bonuses, or it more than 50% of your total compensation is like the stock and bonuses as opposed to the base salary. And I'm certainly at that level now, but like at Intel, yeah, like most of my compensation was base salary, and I think I was like around like 190.
Gotcha.
Yeah.
But you said even now, like about 50% of your total comp comes from like stocks and bonus.
Yeah, like maybe more than half of my comp now at Google is probably stocks and bonuses.
Wow, that's wild.
Yeah.
Okay. And then I know there's like typically there's like a vesting period. I know like when I worked at GM, I think they had like we didn't get stock, but it was like I think a 3 year vesting period for like 401k or retirement contributions. Is there a similar like thing for the stock options?
Yeah, and so yeah, there is. So some companies do like you have one vest event a year. And then some companies do every like 6 months or 3 months. Google actually does vesting every month.
Oh,
So I,
okay.
I I vest every month. I think Google's the only company that does that. I think other companies do like 3 months or 6 months. Yeah.
So if you got, let's say you got some stock options today, when would that vest?
So usually what you get at kind of the big tech companies like the FANG companies is when you started you get like a stock award. So let's say you got 100,000 in base salary and then you got 100,000 in stock awards. The 100,000 stock awards would vest over 4 years. So you vest 25K of it the first year, and then the second year another 25K, third year, and fourth year. You'd also get this thing called a refresher stock, where they would give you a little small award at the end of the first year that would vest on a 4 year cycle. And then at the second year, you get a little refresher too. But it's all these kind of 4 year cycle things.
Okay,
Yeah.
gotcha. All right, good stuff, man. No, I mean, I can definitely see if you know you're my God, like those more senior people that's been there 10, 20 years. I just imagine what they're sitting on in terms of like stock options alone. Not even base is cool, but like the stock options alone, like if you've been there for like 20 plus years, that's like some ridiculous income. So
But I will say I do feel like the Bay Area is like a make a lot, spend a lot place.
okay, gotcha. Yeah. I was just out there recently, like a couple months ago, like not Bay Area and Anaheim, and that alone, I was like, my God, like this stuff is high as hell compared to Texas, like everything, gas and Yeah, so I can and then also not even getting into like real estate. I think I saw some guy on Instagram posted like, "Yeah, I just bought this new house, 700K." And dude, I promise, this is something that you can get in Houston or in Texas for like 100K or 150K. Like it just like the comparison in terms of like what you get just in the real estate alone, it's like mind boggling. So I can
Yep,
definitely
yep, yep.
understand that. I don't know how people like on minimum wage like survive out there. Honestly,
Yeah, I mean, it's hard because it's not like everybody's in tech. Minimum wage, I think, is higher, but it's not enough to cover. But even people who are like, it's hard because even people who are like teachers or things like that, it's very hard, you know?
yeah, yeah, that's exactly what I was gonna say. Like the city workers or teachers, like if you're making like maybe let's just say 80K, because like typically in most places that's a decent living. But like, what do you do in the Bay Area if you're making 80K? Like, are you living like 2 hours away and commuting, or so I don't know, but
No, it's definitely a problem here. Yeah.
okay, good stuff. Hey, real quick, I do want to. I feel like you may have some experience with like salary negotiations. Do you have like any advice or anything there, based on like your experience either at Intel or like getting your job at Google with like negotiating salary or any tips or tricks there?
Yeah, I think that all salaries are negotiable. I think the more senior you get, the more negotiating headroom you have. A lot of people, one thing I think a lot of students don't know is like a lot of jobs have a signing bonus that the recruiter could be authorized to give you a signing bonus and they don't know to ask for it, so they don't get it. And then for more senior people, I think for more junior people, a lot of times there's kind of a more rigid range. I kind of feel like for more senior people, the more vague you can be about it, the better. Like you want them to propose a number before you do, because like the first person to propose a number sort of can anchor the conversation. So like let's say I was negotiating for a job and the pay was, like I thought 100K was a big number, but they were prepared to go to 200K. But if I say 115, they're just going to be like, "Oh, okay, 115." So you don't really know how much you're leaving on the table. So either you can say nothing, or if the real range is 100 or 200K and you said like, oh, 400K, there's
Yeah.
different strategies. There's different strategies to this. Sometimes you don't want to say so high a number that sometimes that you kind of turn them off and blow them out of the water and sound ridiculous, but there's kind of like an art to doing it, you know?
Yeah, that's a good point. And I've heard some people like it's essentially the same thing as what you're saying, but like basically ask like, hey, what's the typical pay range for this role? Like, because like to your point, if the pay range it'd be even worse if it's like 100K and you're coming in there like, hey, the Bay Area is super expensive. I saw a TikTok where somebody was making 400K, but this role is only paying like 150. Like that's not gonna look too good or reflect too good on you. It may look like, okay, hey, this person's unreasonable, or hey, they didn't do their research, or they're just like asking for the world, or whatever the case may be.
But on the same token, and this specifically like people who are underrepresented in tech,
Yeah.
it's kind of just like any kind of low number that is thrown out there that they'll just be like, "Oh my God, this is so much money. I don't know anybody who's ever made this amount of money," but then you're leaving money on the table, you know?
Yeah, that's a good point. I my first internship at Sandia actually, dude, I remember I got paid $33 an hour. And I'll never forget because I was like I was undergrad or finishing up my undergrad, but I called my mom and I was like, "Hey, I can get this internship. They're paying me $33 an hour." I'm like, I'm doing the math, like, "Oh my God, I'm making so much money." And my mom was like, "Baby, you making more money than me." And I was like, "What?" So she was a teacher, a lifelong teacher. And I was like, man, like it just kind of hit me like, man, this is like an amazing amount of money. And so like for that 21, 22-year old, that was like, I'm rich. Like not literally, but it's like you think it's the most money in the world. And then you start having more conversations. And like now I'm like, man, that was not I don't want to like relatively speaking, it's like that was just like that was as much as my mind had been exposed to. I'll put it that way. I guess the main thing is like the more you're exposed to, the more you become aware of like what's available for you and what kind of lifestyle you can live.
Right. And so related to that, another thing I would say is like, it's not something like you're going to kind of get a job offer and then just off your adrenaline, you're going to negotiate. Like you need to do as much research as possible. So,
Yeah.
for example, like you mentioned, like GM, like if I was getting out of college and or getting out of a master's and I was going to go work at GM, it's like I need to talk to people like in the auto industry and just say, hey, can you tell me what's a reasonable range? Like, can I use the career services at my college and say, like, the mechanical engineering grads going at automotive industry, like, what is sort of the range of the salary? Like, a lot of that data is like available, and you sort of need to you need to be able to you need to have as much information as you can going into it, because you're negotiating with a person. You're going to negotiate with a person. It's going to be someone that's like, oh, I'm on your side trying to help you, but they don't work for you. They work for GM. Even if they say they work for you, they don't work for you. So you got to
Yeah.
do that work for yourself,
Yeah, no,
you
that's a
know?
great point. I mean, they'll be super friendly, super nice, and I think part of it is just their personality. But then also, the more money they can save the company, the better. Like that looks good on them. So I mean, I think you got
They're going to get a bonus for that,
yeah, if they meet their budget or whatever, that looks good on them. And so I think all of that you definitely have to factor in. Um, I got two last questions. I know we're over time, but I feel like these are important for me to ask. The first one, man, where do you kind of see yourself going next, like from here in terms of like, are we working up towards the director level? We're going for VP. We're looking for that $1 million payday. You got to keep the wife and kids happy and fed and everything like that. Or are we? You think you want to stay where you're at in terms of like the managerial role, or you want to like switch over in terms of the technical side at Google? Like, what do you kind of think, or like long term, big picture?
I don't really know what the future holds. I don't know that I see myself sort of in any role forever. Sometimes I think like, oh, what if I could be a director or a VP? But sometimes I'm like, oh, well, all these people are starting companies to solve problems. Like, is there a problem that I could solve in sort of a compelling way in my own company, and make money? That's certainly a thought in my mind, but I don't know.
Okay. Fair enough. And I mean, obviously, things change over time. Your viewpoint, your perspective, your interests. Like you have kids now, like that changes things as well. So all of those things have to be factored in. Last question. I'm just kind of curious your thoughts. This is something we used to ask like guests on every single episode, but I'm curious. Obviously, blacks and Latinos are underrepresented in tech, specifically. What do you think can be done, like maybe either on a global or on a national, or even on like a more local level to like change the numbers, like get more representation? What would kind of be your thoughts on that?
It's definitely an issue. It's definitely a problem I've experienced. Like I can't tell you the number of times I've been like the only African American. Certainly lots of times. I think it's like a multi-pronged problem, obviously, and I think it's sort of like a generational problem. I do think on one side there's like an exposure problem. Like even for myself, I gave the example of like I never met anybody black who had a PhD. Even though I grew up with a father that's an engineer, so like people can't like imagine sort of a path for themselves if they don't see it, and they might not even know they don't imagine it. I think that there's sort of I don't know. I mean, there is sort of the investing in sort of like education and things like that, but I feel like that's kind of like the answer that everybody says. I don't know. And is it really, sometimes I think, is it really like a question of sort of underrepresented people getting to the level where, we're the ones like making companies and like creating opportunities? I don't really know.
Yeah, I think to your point, I mean, you say you don't know, but you listed quite a few things there. But I do think it's a combination of all of that. I do think,
Yeah.
just me personally, like the exposure part. I definitely think the opportunity part. If a door's not being open for you, go create your own door. And so I think that's another component of it. I mean, it's not as simple as me saying that. There's a lot of work
It's
that
not
goes
just like, oh,
on.
like we're going to go, me and Andrew tomorrow are going to go do it. But like, yeah.
Yeah, but no, I think also like I think you're doing some of it as well. Like black man at Google, super talented, intelligent. Um, the representation, your willingness to come on the podcast, your willingness to speak to others and mentor others. I think all of that is a part of the equation. So now we just got to get you to like start some amazing startup and then employ some people, and you'll kind of complete
Yeah.
the checklist of
I'll
stuff
complete
that
the
we just
circle.
talked about.
Yeah.
Yeah. Good stuff. Hey, man, I know I had you on here longer than I thought I would, but I appreciate your patience. I appreciate your presence, all the insight, the advice, and everything that you shared. I do want to like just open up the floor in case there's anything that I missed or that we didn't get a chance to discuss that you maybe want to talk about or highlight real quick. So feel free, like open the floor up to you. Like if there's any comment or shout out or anything, like feel free to like mention that or do that.
Nothing specific, but I would say, yeah, if people have questions for me, they can definitely like find me on LinkedIn. I'm around. Generally, like to think I'm pretty responsive. So,
Okay, good stuff. Is it all right if I put your LinkedIn, the link to your LinkedIn profile in the bio in the description of the
oh yeah,
podcast?
sure.
Okay, we'll do. We'll do definitely. Yeah, and I encourage you guys to check out Tyrone. I mean, reach out to him. Obviously, he has a wealth of knowledge and insight and advice for people. So feel free to hit him up. And Tyrone, to you, thank you again for coming on the show. It's been a joy, man. It's been a great pleasure. Definitely hope to have you on again sometime in the future. I know you'll be visiting Houston at some point, so hit me up when you do, and we'll make it happen in person and kind of go from
Oh,
there.
some barbecue. Yep.
I'll hook you up, man. I know a couple spots I can take you by some barbecue for sure. You know, y'all probably don't have nothing like that in the Bay Area.
Oh no, we don't. Absolutely not. We
It's probably
don't.
just vegan barbecue or something like that, you know.
It's tofu.
All right, cool. We'll make it happen. And then for you guys watching, I appreciate you all for staying tuned. Make sure you check back next week where we'll have another great interview. I hope you all take away a lot of great value from this interview and this episode with Tyrone. But stay tuned. Take care.